I want to start our section on estimation and planning by exposing to you how bad we are at estimating. All right, so a lot of people think we're pretty good at it and we could get better. I want to prove otherwise. I want to start by showing you how bad we are, and to do that I want to expose a few things. So you got to help me out here. When in a project can we make a perfectly accurate estimate about how long it will take to do? When it's done. At the end, we're 100% accurate. It finished yesterday. It took this long. That's great. At the beginning of a project, are we 100% accurate? No. We have some range of accuracy we've missed by some amount. As we go through the project, that range narrows because we learn things, we get better. And we actually get better estimates over time until at the end we can make a perfect estimate. This is called the cone of uncertainty because it looks like a cone. If we lived in the southeast United States, we'd be very used to this cone of uncertainty. Hurricane is here, it's going to track along this potential track. That's the cone of uncertainty in action. The problem is, up front is where we make our real estimates for projects, right? How accurate are we up front? Are we plus or minus 5%, 10%? What do you think? 50?
50-50 each direction.
50-50 each direction, so plus or minus 50. What else? Any other ideas?
20.
20? It's much worse than you think. According to PMI, up front, we could be off by as much as 400%. Okay? Not a good situation. This side of the chart is we underestimated and finished late. This side is we overestimated and finished early. And to put this into context, if we thought that a project would take 6 months, that was where we thought 100% was, it could take as little as a month and a half, 1/4 of that time, or as much as 2 years, 4x that time. So anybody want to go to their boss and get budget for somewhere between a month and a half and 2 years? How's that going to work for you? Right? It doesn't work very well. Now, PMI, Project Management Institute, they do have ways to narrow this cone fairly quickly. And the cone narrows something like this, and it gets a lot better in a hurry, but we're still stuck with the fact that up front is where we're making all of our estimates and making a lot of our decisions. It's not a very good situation to be in. And when you look at that, a lot of people look at it and think, that just doesn't seem right. We can't be that bad. Right? I mean, that's really, really bad. So a guy by the name of Todd Little, he had access to a lot of data about projects, and he said, I know where they finished, I know what the actuals were, I know what the estimates were along the way. I'm going to scatter plot all this data I have access to, and I'm going to prove PMI wrong. And so he took his data and he started scatter plotting it. And he started to notice a pattern. And he started to notice more and more of a pattern. And this whole part kind of got filled in pretty dark. And the rest of the chart kind of had random dots. He proved PMI wrong, right? What did he prove? What part did he prove? We tend to always underestimate, right? Well, duh, we finished late a lot. Not surprising. What was surprising was he proved that this number was not right. Nobody expected him to prove that, but this number is wrong. It should be this. What he found was projects can be as bad as 10x. In other words, a 6-month project could take somewhere between 6 months and 5 years to complete. That's not a good situation, is it? Okay? This is what we're up against when we're doing estimation. And people tell me all the time, Bob, shouldn't we be comparing actuals to the estimates and getting better? Don't you think they did that? Bob, shouldn't we learn from previous projects? Don't you think they did that? This is where we are as an industry today. It is not a pretty picture. And today, according to the Chaos Report, we actually finish on time with high quality and the desired feature set only about 31% of the time. And you can see why. We've got a big hill to overcome here. Okay? One thing I want to point out about this, though. This picture is ugly, but let's change it just slightly. What if instead of the 100% line being here, we had the 100% line maybe going through here? Some projects finish early, some projects finish late. You start to have some cancellation, and the average project starts to finish on time. So part of what we would need to do with our estimation and planning is figure out how can we move that line, given this data, how can we move that line and make it be less problematic? So that's what we're going to talk about. Here's the scenario. You are in a company trying to do release planning. And the team has estimated all of the work, and the team says there are 200 story points. I think in the book it says units of work, but let's call it 200 story points of work in this particular release. Okay, 200 story points. We know that our team's velocity is 20 story points per sprint. That's what they finish every single sprint. They're an amazing team every time they get 20 of them done. Here's my simple question. If you spent more than a few seconds thinking about it, you've overthought it. How many sprints will this project take to complete? 10. 10 sprints. Would it surprise any of you if I said you only have about a 10% chance of that being right? What kinds of things did we not take into account with this estimate?
Emergence.
Emergence, new things. We can call that scope creep. That's one of those things that happens a lot. What else?
Time off.
Time off. So we might have some capacity issues we didn't take into account. What else? What else happens on projects?
Maintenance bugs.
Maintenance and bugs. So basically code quality.
Impediments.
Excuse me?
Impediments.
Impediments. What else? Mistakes. Bugs, code quality. What about things like, are our estimates 100% accurate? Probably not, so there could be some estimate variance. Do you ever have a time when you run up against something you didn't think about ahead of time, an unknown? Unknowns can happen. Basic risks could happen. All of these things and many others could occur during this process. And we didn't account for any of them. What we did was a very basic equation. Work divided by velocity equals time. That's what we did. And that is a great looking physics equation. But it doesn't work worth a darn for developing software. Now let's back up a step and let's talk about the release dates in general. PMI says you should never give a single release date. I find this really interesting because I see ad after ad around the world that says we want to hire project management professionals, PMPs. Well, they have been trained that they should give a range of dates for the release. In fact, they're supposed to give best case, worst case, and then something between the two, which I'll call average. I think they call it likely. Which one did we give with this estimate? Best case scenario. So think about how we run our software worlds. We give best case scenario up front, and then we only ever give bad news. Does that make sense to try to do? Yet that's what we do. Why don't we give ranges for these things anymore? It's an interesting question, and I think I know the answer. What?
Cost accountants.
Yeah, it's kind of interesting. I was the VP of a company for a while, and when somebody came to me, they might say, Bob, this project will take somewhere between 6 and 8 months. What I would hear them say is, Bob, this project will take 6 months, blah, blah, blah. I only ever hear the lowest one, right? So we stopped even trying to give ranges. But if you had a choice, if your job depended on it, which one would you give? Best, worst, or average?
Worst.
Worst. Now think about what that gives you. You give worst case up front, and you only ever give good news from that point forward. Very different scenario. If your teams, they know you've given best case scenario, and something happens that now best case is out of play, what happens to their morale? Goes down. And what did we say about morale going down? What's going to happen to velocity? Goes down as well. If you've given worst case and they're exceeding expectations, what will happen to their morale? Goes up. And what will happen to their velocity? Goes up. They will actually make that better and better and better. It'll be a self-feeding cycle that will increase our ability to meet our date. So we have a problem here. We have to overcome this. A guy by the name of Jim Shore wrote a book called The Art of Agile Development. And in that book, he had a chapter called Risk-Adjusted Planning. It's actually in your workbook, so I'm not going to have you read it now, but it's there so you can read it later. And in that chapter, he said, we need to be able to encompass this stuff with some kind of number so that we can use it in this equation in a meaningful way. And so his first attempt, and the one that actually worked, was he extended the equation and multiplied everything by a risk factor. And he said, if we can encompass this with a number corresponding to it, we can make the rest of it work out. And so here's what he came up with. For the best case scenario, if the risk factor is 1.0, we haven't changed the equation at all, have we? It's still best case scenario. The problem is we only have about a 10% chance of finishing on time or early under that scenario. A risk factor, assuming your team does testing well, in other words, you have a good definition of done and you're reaching it every sprint, he said a risk factor of 1.8 is probably your worst case scenario, and you'll have about a 90% chance of that becoming true. So you'll meet or exceed your date, or meet or beat your date by 90% of the time. And what's between 1.0 and 1.8? He took a risk factor of 1.4, and that's about the 50-50 line. Now let's assume that you have a team that's doing well with their testing and they can use a 1.8 risk multiplier. 1.8 times 200 divided by 20, now we think 18 sprints. And that gives us a 90% chance of finishing on time or early. Now people look at this and they tell me one of two things. They say, Bob, this is the old joke. Take all the estimates, multiply them by 2, and that's the real number. You didn't use 2, you used 1.8, but it's pretty close. Let me ask you this. Did I change any of these estimates? I didn't change any of them. This multiplier factor is accounting for the dysfunction in our process. These things happen all the time. If we don't account for them, we will continue to deliver products late. So we're simply accounting for that with the 1.8 multiplier. Second point I want to make. This team does 20 story points every sprint. After 10 sprints, how many story points will they have completed? 200. Will it be that 200? No. Probably not, because of all these things over here. That's the point we're trying to make. We have to account for the dysfunctions in our system. People tend to account for them in other ways. We tend to overly inflate our estimates already. So the goal here is, let's have people worry less about being perfect and having them overinflated. Account for it in a different way. Just account for it systemically in our planning. And this becomes a lot easier. Give me your best estimate of what it will really take. And they say, what if I'm wrong? Estimate variance is in here. Give me your best estimate of what this project will take. Well, what about scope creep? It's in here. What about if something happens we didn't think about? It's in here. Right? All of it can be done at this very high level rather than each individual level. It takes a lot of pressure off teams when we start estimating in this way. Make sense?